Please send the message to your friends to join the meeting. Okay, students, let's start today's lecture. Am I audible properly? Please post the message. Am I audible properly? Please post the message. Pooja, are you hearing me? Omkar, am I audible, students? Please post the message. Okay. Okay. So in yesterday lectures, we see what is the difference between truth table and excitation table. So if you consider the truth table, then it gives the output values in terms of input values. Truth table is nothing but it gives output values in terms of input values. But if you consider the excitation table, then it gives the input value in terms of output value. In terms of output value, we already seen the number of examples how to convert the one flip flop to other flip flop. Also, we seen what is the advantages of flip flop. So there are the three advantages of flip flop. First, uh, first advantage is the switch. Means flip flop, you can use the flip flop as a switch instead of the mechanical switch. You can use the switch using flip flop. These are the applications. This is the first application. This is the second application, which is the register. So register is nothing but it stores more than one bit information at a time. It stores one more than one bit information at a time. But in flip flop, you can store only one bit information at a time. So this is the second application of register, and this register is the heart of any processor. Okay, we already discussed about why register is important as concerned to the any processor. Okay. uh, Next, this is the counter. This is the third application of the flip flop. Counter counts the event which is happen outside the microprocessor or microcontroller. So while manufacturing the counter or while designing the counter, you can use the flip flops. Okay, you can use the flip flop. So in yesterday we seen what is the register. We already seen the flip flops. Okay. Now we will see what is the function of register. What is the function of register? So this register holds large quantities of data than individual flip flop. Means flip flop stores one bit information, but register store more than one bit information. If you want to use to store 4-bit information at that time, here 4 flip-flops are used. Means when number of flip-flops comes together, then it forms the register. Okay, then it forms the registers. So register, it is the extension of flip-flop. Means this is the extended version of the flip-flop, can store multiple bits, and registers are commonly used as a temporary storage in a processor. Okay, so this register is the heart of any processor. uh, Next, we already seen the types of registers. There are the actually two types of register. First is the buffer register, and second is the shift register. Okay, and in the shift register there are again subtypes. First is the serial in serial out register. Next is the serial in parallel out register. Next in parallel in serial out register. Next parallel in parallel out register. Next bidirectional shift register, and next universal shift register. Okay, so here shift operation is performed using shift register. So there are the two ways to classify the register. One way is the buffer register, and second is the shift register. So now we will see what is the function of shift register, what is the function of buffer register. So what is the meaning of buffer? What is the meaning of buffer? Anybody? What is the use of buffer in electronics, or what is the use of buffer in computer engineering? What is the purpose of buffer? Anyone can give the answer of this question? You can also put the message regarding to this. If you know about the buffer, then put the message regarding to this buffer. Please put the message, because you already studied this buffer in first year engineering. Basic electronics engineering, there is one chapter, operational amplifiers. In the operational amplifier, there is one application of this operational amplifier is the unity gain amplifier. Okay, so this unity gain amplifier, it is also called as the buffer. So what is the use of buffer? Anyone? Because in the first year you study the unity gain amplifier. So what is the function of unity gain amplifier? Here you apply whatever the input, same input is passed at the output side. Okay, same input is passed at the output side. That's why it is called as the voltage follower. Means whatever the voltage is applied at the input side, same voltage you get appear at the output side. So what is the function of buffer in electronics? In electronics, you want to transfer information from one location to another. Okay, this is the most important application as concerned to the electronics. Okay, we are using the cell phones. Okay, we are here we are taking one online meeting. So here my voice is transferring at your side. Okay, so for this purpose, whatever the information is transferred from one place to another, this information first stored into the buffer. This information is first stored into the buffer, and then this information is transferred. Okay, so what is the function of buffer? Whatever the information is transferred, this information first stored into the buffer, and then this information transferred from one location to another. So what is the actual use of this buffer? Actually, buffer increase the driving capability of data, or it is also used for impedance matching. Means you already know about the concept of impedance matching. At the output side, your output impedance, it should be low, and at the input side, your input impedance, it should be infinity. These are the ideal quantities as concerned to the impedance. Okay, so here you have to transfer the information from one place to another place, and both these locations have different impedance. Okay, and if you want to make the communication in good manner, then it should be required to match the impedance. It should be required to match the impedance. Means its output impedance it should be low and input impedance it should be infinity. So this buffer do this activity. Okay, it matches the impedance matching, or it avoids the loading effect. It avoids the loading effects. So point is noted here. Whenever you want to transfer information, whenever you want to transfer the data from one place to another place, at that point you should first place this information into the buffer. But why we place this information into the buffer? Because it increases the driving capability of this data. It increases driving capability of this data. So always you keep in mind, you keep in mind, whatever you want to transfer the data, this data first stored into the buffer, and then you can transfer this information. Okay, so this is the application of buffer. So this is the uh, first type of the register. This is the first type of the register, which is the buffer register. So here three flip-flops are using. Okay, which flip-flop are using? D flip-flop is using. Here we are using three D flip-flop are using. And what is the meaning of this D flip-flop? D flip-flop is nothing but the delay flip-flop. D flip-flop is nothing but the delay flip-flop. Okay, means here here you transfer the information at the input side to the output side when one clock pulse is completed. Okay, when one clock pulse is over. Okay, means at every clock pulse you transfer the data at the output side. You transfer the data at the output side. So here for transferring the data, here you always use the D flip-flop. D flip-flop is nothing but the delay flip-flop. And here you observe that there are the three flip-flops are used. That's why here you can transfer the 3-bit information at a time. You can transfer the 3-bit information at a time. Okay, so here you take one example. Here you assume that here you transfer the data 1, 0 and 1. Okay, so first this one is applied at this input. Okay, next this 0 is applied at this input. Okay, next this 1 is applied at this third D flip-flop. Okay, and when one clock pulse period has completed, then this one is came across this came at the output side. And this one is came here 1. Okay, this 0 is came here, and this one is comes at the output of the third flip-flop. Sorry, output of the third flip-flop. Means here you get the output as 1, 0 and 1. Means here you transfer the 3-bit information. Here you transfer the 3-bit information, and how much time, how much clock pulse is required? Only one clock pulse is required. Okay, means when one clock pulse is completed, then you get the input data at the output side. You get the input data at the output side. Okay, so this is the example of the buffer register. So what is the use of buffer? Whatever the information you want to transfer, this information is first put into the buffer register, and then you can transfer this information from one place to another place. And in the register, which flip-flop you are using? D flip-flop is always using. Okay, D flip-flop is always using, because in the D flip-flop, whatever the input is at the, whatever the value present at the input side, same value is present at the output side. Okay, so here only some time takes to pass this value from one place at the input side to output side, and this time it depends on the period of clock pulse. Okay, do you understand what is the function of buffer register? Please put the message. Do you understand what is this buffer register? Please send the message. Do you understand what is the buffer register? This is one of the type of register. In register, you are using the D-type flip-flop, and here there are the 3 D flip-flops are used. That means you can transfer the 3 bits at a time. But if you are using simple flip-flop, then you can transfer only 1 bit at a time. So do you understand this concept of this buffer register? If you understand this concept, then please put the message or say something. Unmute from your side and say something. Pooja, unmute from your side.
Yes, sir.
Understand झालं what is the meaning of buffer register?
Yes, sir.
तुझ्या बफर रजिस्टर काय कसा वर्क होतो हे समजलं का?
कळलं.
ओके. संदेश भोसले आहे का? संदेश भोसले, प्लीज अनम्यूट.
येस सर.
संदेश, हॅलो संदेश,
आवाज येतोय सर? बरं,
आवाज येतोय तुझा.
हा
संदेश,
समजले सर. हा समजले सर.
संदेश आवाज येतोय माझा तुला?
हो येतोय सर.
ओके. सूरज आहे का तिथे? सूरज खराडे, सूरज खराडे. Suraj Karade, unmute from your side and say something. Do you understand or not? Suraj. Suraj is there. ऋषी शिंदे, ऋषी आहे का तिथं? ऋषी,
हो सर आहे.
ऋषी
आहे सर.
अंडरस्टँड झालं बाळा बफर रजिस्टर काय आहे तो? But at least send the post. At least you send the post. Do you understand or not? What is the buffer register? Please, all of you.
ओके.
शार्दुल भोसले. I'm not getting any response from your side. And today only 13 students attending this meeting. Sweta Gaikwad. Okay. I'm getting response only from Sweta. What about others? Okay, Sandhya. Okay, listen. I repeat this point again. This is the first type of register, which is the buffer register. Okay. So first, one point is noted. What is the use of buffer register? So buffer register is used for storing the information. And which information you store here? Which information store here? which data you want to transfer from one place to another place. Okay, means for increase the driving capability of any information, means if you want to increase the driving capability of any data, at that time this data it should be stored into the buffer register. It should be stored into the buffer register. So what actually does this buffer register? Buffer register increases the driving capability of the information, and it also match the impedance. It also match the impedance. Okay, means you already know about the concept of this impedance. At the output side, your output impedance it should be low, and at the input side your input impedance should be high. Okay, and here you transfer the information from two different locations, and at that time impedance of these two locations are different, and you cannot transfer information directly. You cannot transfer information directly from one place to another place. So to avoid this impedance in matching, you put the data, which data you want to transfer, first place into the buffer register. This is the application of buffer register. So here we take the example of this buffer register. Here we are using, here we want to transfer the 3-bit information at a time. 3-bit information at a time. That's why here we are using 3 D flip-flops. Here we are using 3 D flip-flops. So your input data is 101. Your input data is 101. So this one is placed at the first D input first input at the first D input. Okay. Second 0 is placed at the second flip-flop. Okay, this is the 0. This is your second input, and this is the your third. This one is placed at the input of the third flip-flop. Okay, and here when one clock pulse has completed, then this data is transferred at the output side. Okay, means here when one clock pulse has completed, then this one is passed at the output side. Okay, so this one is present. Okay, when the, and here you observe that same clock pulse is applied to this 3 flip-flop. Same clock pulse is applied to this 3 D flip-flop. So within one clock pulse you get the output. You get the output, means this 0 is passed at this output side, this 0 is passed at this output side, and this 1 is passed at this output side. Means you can say you can say that if within one clock cycle you can transfer the information at the input side to the output side. Okay, so this is the operation of the buffer register. So in this buffer register, which flip-flop you are using? D flip-flop you are using, and all these flip-flop have connected common clock pulse. Have connected common clock pulse. Okay, do you understand now? Sweta Gaikwad, do you understand now? Prachi, good. Okay. जर समजलं नसेल तर पुन्हा पुन्हा सांगत चला. आपल्याला भरपूर वेळ आहे. आपल्याला काही पुढे जाण्याची एवढी काही घाई नाहीये. एखादा कन्सेप्ट नाही समजलं तर तिथे सांगा सर रिपीट करा म्हणून. आणि समजलं असेल तरी सुद्धा तिथे म्हणा सर आय अंडरस्टँड. ओके, तुमच्याकडून काहीतरी रिप्लाय करू दे मला. ओके, ठीक आहे. आता नेक्स्ट पॉइंट घेऊ आपण. आज फक्त 11-12 विद्यार्थी फक्त अटेंड आहेत. प्रॉब्लेम काय आज? ठीक आहे. Next type of register is the shift register. Okay, we already seen first type, which is the buffer register, and second type is the shift register. So there are the 4 types of shift register. First is the SISO, it means serial in, serial out. Second, SIPO, it is nothing but serial in, parallel out. Third is the PISO, is nothing but parallel in, serial out. And last is PIPO is nothing but parallel in, parallel out. Okay, so these are the subtypes of shift register. Okay, these are the types of the shift register. So here you observe this figure, means you can explain diagrammatically of the SISO operation. Okay, so here you see here data 10110, this data is passed at the output side. Okay, but it pass from the serially. Okay, and if you observe the SIPO, here you apply data serially, but you take the output parallelly. Here you take the output parallelly. And if you observe PISO, in the PISO type, here you apply data to the D flip-flop parallelly, but you get the output serially. You get the output serially. And last type is the PIPO, is nothing but here you apply the inputs to D flip-flop parallelly, and also you get the output of the D flip-flop is also in the parallel form. Okay, so these are the types of the shift register. These are the types of the shift register. Now we will see one by one. This is the shift register construction. Means one point is noted in your mind. Always you use the D flip-flop. Always you use the D flip-flop for storing the data. And always we apply the same clock pulse to each flip-flop. Means this is known as the synchronous clock pulse. This is known as the synchronous clock pulse. Means here there are the three flip-flops are using, and for each flip-flop you apply same clock pulse. Here you apply same clock pulse. It is known as the synchronous clock pulse. It is known as the synchronous clock pulse. Okay, so this is the construction of shift register. This is the construction of shift register. Here sentence is shift registers are comprised of D flip-flops that share a common clock input. So this is the construction of shift register. Means in this construction, point is noted here. You are using the D flip-flop, and same clock pulse is applied to this D flip-flop. It is called as the synchronous clock pulse. This is known as the synchronous clock pulse. Okay, so this is the construction of shift register. Now we will see one by one type of this shift register. So this is the first type, which is the serial in, serial out shift register. Means here you have to apply input serially, and here you have to get output serially. Okay, means here a serial in, serial out shift register has a single input and single output. Here you observe that this is the single input and this is the single output. Okay, so this is the construction of SISO. Means here you apply input serially, and also here you get the output serially, and here you are using the D flip-flop, and here you apply the clock pulse. Here you apply the clock pulse, which is in the synchronous form. Okay, so here suppose here you want to transfer data 1, 0 and 1. This information is transferred. Okay, this information is transferred. So here you are using this three flip-flop. This is the first flip-flop, this is the second flip-flop, and this is the third flip-flop. Means here if you want to transfer 3-bit information, then you can use the 3 D flip-flop. Okay, so when one clock pulse is completed, then what happens? This one is present here, this one is present here, this 0 is also present here, and this one is also present here. Okay, means when this one clock pulse period has completed, then output of the first D flip-flop is 1, output of second D flip-flop is 0, and output of third D flip-flop is 1. Okay, means here you get the output 1D1. Okay, here you get the output 1D1, but at the output side you want the 101. Here you want actually 101. This output you expected. This output you expected. But after completing the one clock cycle, after completing this one clock cycle, here you get only one bit, which is the one, which is the one. Okay, so you again apply second clock pulse. You again apply second clock pulse. Then what's happened? This one, this one is transferred at this at location. Okay, this one is transferred at this location, and this 0, this one is already you already get, this one is you already get. Now this 10 is shifted. Okay, means first this one, this 10 is present, this one and this 0. Now this 10 is shifted to next D flip flop. So here 1 and this is the 0. So this is the output of second clock pulse is completed. Okay, means first at the first clock pulse you just get this 1. Okay, now when you apply the second clock pulse, then you get this 0, and you apply the third clock pulse, then you get this 1. Okay, means here you require 3 clock pulses. Here you require 3 clock pulses. Means if you have n bits you want to transfer, then n clock pulses you are required. Then you require n clock pulses. We understand this is the most important point for the SISO shift register. If you want to apply the n bits of information, then you require n number of clock pulses. Then you require n number of clock pulses. Do you understand this? Please put the message. Okay, Sandesh Bhosle. Okay, students, I think we stop here because today's count is very less. Only 9 students are attending this meeting. Okay, one is also Vaishnavi Karan is left now. I think some network issues regarding to this yesterday's in काल खूपच पाऊस झालेला आहे, त्यामुळे सगळ्यांना अडचणी आल्या असतील. बऱ्याच ठिकाणी लाईट नाहीये. तर पुढचे पॉइंट खूप इम्पॉर्टंट आहेत. सो टुडे वी स्टॉप हियर. जस्ट वेट 2 minutes. I will take the attendance. Just 1 minute. Wait.